Hi everyone, I'm Giripat Garenu. My seat number is 20 and I'm from 5/18. And this is exponential and logarithm function graph. So this is
Mr.
the
Mexico,
group member.
and number 5.
My name is Dayton Manaku, number 16.
So the introduction is to understand the graph of the exponential and logarithm functions and to know between each different function and formula. The objective is to study the different types of exponential and logarithm formula in the form of graph. So we study the relation between exponent and logarithm and to know how variable affect the graph. So now we come to the procedure. First, determine the value of all the constants, set up the function start. And the second is set up the variable value into each of the equation. And lastly, make the graph for each case and compare with the graph result. So now we come to the exponential graph.
Let's start.
Yeah, as he said. So the first graph, as we know that it's determined that it has more than 0 but less than 1. We can see the difference between blue line and the orange line. The orange line is the growth exponentials, but the blue one is decay exponentials. We can see it's basic at 0.7. It is the values that's 0 where a is more than 1. And for this graph, you can see that it's basic at 7, and the gray is the growth exponentials, and the yellow ones or the orange, if you can see it, are that is decay exponentials.
And the next graph, as you can see here, it's a decay from the top. The gray graph is y equals to a times x, and the yellow one is y equals minus a times x. Both of the graphs are pretty the same. The top one is a decay, and the bottom one is exponential growth. And they meet at 12 and 13. And this graph is almost identical as the same one. It's a more than 1. It's just the another version of the before graph. It starts from a. Yeah, it starts from 1, and the gray line it's exponential growth, and the yellow one is exponential decay.
Okay, and for this one, we can determine that it has more than 0 but less than 1. The difference between y that is a times x, which is the blue ones. Okay, the orange one that is y equals a times x minus h, and the gray one that is y equals a times x plus h. The graph are exponential decay, but they are different in transformations. These results are similar to the person, but this one not move up or down. The result is move left or right. due to the constant plus or minus with x value. Okay, and for this one, that's y equal x times x plus k. Even though it is the yellow one, they have different transformation. That is, the color of the yellow is the basis of all the equations, but the green one is laid above the true graph because the k constant plus with the functions equations made the graph go up.
Next one is a is more than 0 but not more than 1. And the blue graph is y equal to a times x minus h, and the yellow one is y equals to a times x, and the green one is equals to a times x plus h. When we determine that a has more than 0 but less than 1, we can see the difference between the graph uh, the graph yellow, which and the graph y equals to a times x minus h, which is the blue one, and the graph y equals to a times x plus h, which is the green one. All the graphs are exponential decay, but they are different in transformation. These results are similar to the previous one, but this one does not move up or down. The result is a move left or right due to the constant plus or minus with x value. And here we have a more than 1. So the green graph is y equals to x times x plus h. The orange one is y equals to a times x, and blue one equals to a times x minus h. All the graphs are exponential growth, but they are different in transformation. And this graph is also similar to the previous one, but it's just swap. This one does not move up or down. This result is a move left or right due to the constant plus or minus with x value. This graph is a more than 0 but not more than 1. And the only graph we see here is y equals to a times x. This graph looks like a parabola which has absolute. This one also has the absolute, but the constant number is more than 0, but is not more than 1. The constant makes the graph upside down.
Okay, and how about this graph? It's same to the previous one, that it is an absolute graph. We know that the constant and the number and 0, so it's not the upside down as the previous one, but it looks like same. So how about this one? So how about this graph? That's a is more than 1. We determine that r has more than 1. We can see the difference. The graph y equal a times a bs and x, which is the orange graph. This graph looks like a parabola that has an absolute, and this graph is rotated normally because the value of n is more than 1.
So now we come to logarithm graph.
So in the case 1, the graph is assumed A is 2, B is 3, and C is 4. X value is started from 0.5 and in 6.5. When X value is 0.5, the value of 3 line in the paragraph will less than that the value of the X when is 6.5. So all 3 line will increase. The result of this graph is the base will increase, the slope will decrease, and the graph are intersect in if x equals 1. Next is the case 2. In case 2, the value of A is 0.5, value of B is 0.6, and C is 0.7. X values is started from 0.5 and in 6.5. When X value is 0.5, the values of all 3 lines is more than X value and it's 6.5, so the base are decrease and the slope will increase. Next, case 3 is the type of graph that move up and down. We assume the value of 3 lines are different in 3, so k is equal to 3. In summary, if k is positive, graph are increased, but if k is negative, graph are decreased in 3.3 minus 3.
So if you take a look, like the case 4 is just like the same case as case 3. The different thing is just only the case 3 is more than 1 and case 4 is less than 1. But these two cases reflect each other with the x-axis as a reflector. So this is the case 4. So now we come to case 5. The value of A is 2 and the value of H is 0.4. The base of 3 line are like go up and the slope go down. And last but not least, we come to the case 6. The value of A is 0.5 and the value of N is 0.4. So the base go down and slope go up.
Okay, so for the conclusion, the thing that we know from the conclusions of learning the exponentials and logarithm graph is we know that the graph result have opposite way in the graph. We also know that the logarithm curve is a reflex of the exponential curve too. And next, you know the benefits of the logarithm and exponential that we can imagine the pictures of different kind of exponential functions and logarithms. We can see how they are different. That is all about logarithm and exponential graph. Thank you.
Yeah, so thank you for listening. Goodbye.
Thank you.